Hello and welcome to Easy Maths. In this lesson we're going to focus again on simplification of surds, though this time around we're just going to take it a notch higher from where we left it last time, as we do some more operations on simplifying surds. So let's turn to the day's objective. As start off, we're going to focus attention on some questions, and we have the first one there. We've been given 2 plus root 3 times itself, and so we are supposed to simplify that. At this point, students are familiar with the fact that when you're given two brackets, you're multiplying together. Every term in one bracket is multiplied by every term in the other bracket, and then simplified appropriately. In this case, that's what we're going to do. And so as we multiply every term with in one bracket with every term in the other bracket, this is how we write it, and just expand so that you'll get 2 root 3 plus 2 root 3, and then we have a 3 there. And therefore notice that the two middle terms are similar, and you just add to get 4 root 3. The 4 and 3 can be added to get 7. Therefore the answer will be this one here. This is a typical example of a perfect square, which is an identity in algebra. Similarly, we're given another similar question like this one, only that the signs between the two terms is negative in both cases. We just expand like we've done in the previous case, and it turns out this way. Therefore the answer will be simply 8 minus 2 root 15. Expand the way it should be done, having written it this particular way, and you get 8 minus 2 root 15. For both of those two examples, there's something that should be observed. When you multiply root 3 times root 3, you should get 3. When you multiply root 5 times root 5, you get 5. And again, root 3 times root 3 gives us again a 3. Root 5 times root 5 is 5, and root 3 times root 3 is 3. And therefore, the two answers should appear as, or should be as they appear on your screen there. Going on to another question. This is a typical example of what we call the difference of two squares. It's very similar to the first case here, only that the signs between the two terms are opposite. We have a positive and a negative here. So multiplying every term in one bracket with every term on the other bracket, we get this sort of a thing. And of course, we simplified this sort of an expression here. I must say the two middle terms are the same but opposite signs. Therefore, they will reduce to 0, and the 4 minus 3 would be 1, and therefore that is simply the answer for that expansion there. We have another question which is similar to this other one, number 2, but the signs between the two are again opposites, plus and minus. So expand it this particular way, and you reduce to this particular expression, which the root 15 is positive and negative here, so we'll reduce to 0. We just have 5 minus 3, which is 2. Turning on to a different sort of question, we have this one here. Now, no two terms are similar in these two brackets, and therefore we just expand the way we have done in the previous cases. Although as you simplify the roots, they'll turn out slightly different from what we have had so far. We'll have 3 root 2 times root 10 will be 3 root 20, and 3 root 2 times root 2 we get 3 root 4, and then we have here root 50, and it's a negative, and then we have root 10. Notice that root 20 and root 50 can be simplified further, since they are not sides in their simplest form, and so we write this particular way: 4 times 5 to represent 20, and 25 times 2 to represent 50, which if you simplify that, you get 6 root 5. The reason is the 4 we'll find the square root to get 2, that 2 is multiplied by 3 to get 6. In this case, the 5 we find the square root, 25 we find square root to get 5, so we have 5 root 2 for the third term. Again here we know the square root 4 is 2, so we have 2 times 3, which is 6. And then, having written this, we just rearrange the terms to get this sort of an expression here, and that becomes our answer. Turning on to the last question, we have this again, in which case no term in any of the two brackets are similar or related in any way, so we just expand the way we've done in previous cases, and so we'll get 20 root 12, 12 root 10, 10 root 18, and 6 root 15. Again, 12 and 18, the root 12 and the root 18 can be simplified further, as indicated by this bracket, this root and this root here. Square root of 4 is 2, so we multiply with 2 with 20 to get 40, and square root of 9 will be 3, so 3 we multiply with 10 to get negative 30. And therefore we have it this particular way, and that is our answer. This is necessary to know, although the only additional concept that students do not know at this point when they are approaching questions of this nature is the fact that we have roots multiplied by themselves which reduce to a rational number, like root 3 times root 3, or root 5 times root 5, or other roots that we have in the questions there. So these are just using the concepts of algebraic identities of either perfect square or difference of two squares, or just expansion of quadratic equations when we are given two brackets and multiplying together, like in the last two cases, and simplifying appropriately. So let me just mention some summary here. When we are given a plus b squared in algebra, that we told reduces to this. When the sign between the a and b is negative, like this, it should reduce to this one. The difference between the first expression and the second one is that the middle term, the signs are positive and negative respectively, as they were here, positive and negative respectively. These two are typically, these are typical perfect squares, and we should be familiar with them at this point. The third case is a plus b and a minus b, which is like the two signs plus and minus, but the two terms a and b appearing in both brackets. Those ones reduce to what we call the difference of two squares, like a squared minus b squared. Similarly, if you have a plus b and c plus d, like in the last two cases, just expand and you get a long expression like this, 4 terms, ac, ad, bc, and bd. Another thing, when you have root a squared, since square and square root are reverse operations, this will simply reduce to an a, like this. And again, root m times root n, as we said in a previous lesson, should be root mn. And a root m times b root n should reduce to ab root mn. And having thus said, I've come to the end of that lesson. Please check out for more as we go on with rationalizing of denominators, as we go to conclude our series of lessons on Surds. Please like, share, subscribe. I'll always appreciate. Thank you.